Now, for one that looks like this, I would highly recommend that you do the following. First of all, the denominator says square root of x. Just view it as x to the power of 1/2. And then what you can actually do is you can split it. Every term in the numerator can be written as itself over the denominator, right? You see what I mean? Just split it and then simplify and do term by term integration. So here, remember your properties from exponents, you subtract them. So here, that'll just be a single x, but it'll be 3 minus 1/2, which is 2 1/2, which is 5/2. Plus, here this will be x to the 1/2, and here if you bring it to the top, it'll be x to the negative 1/2. And then do the same rules of integration where the antiderivative term by term, you add 1 and then divide by that new power or multiply by the reciprocal of that new power. And if my mental math is any good, this one should be 2/7 x to the 7/2 plus 2/3 x to the 3/2 plus 2x to the 1/2. Yep, 2x to the 1/2. Let's see. The derivative of this is that. Yes, the derivative of this is definitely that. And the derivative of this looks good. And just put a plus c. So this is money. If you want, you could also do this. This would be like 2/7 the square root of x to the 7th plus 2/3 the square root of x cubed plus 2 square root of x plus c. Same thing. This is with radicals and this is with rational exponents, whatever they prefer. Over here, does this look like a u substitution? It does, because the derivative of this would be a power of 2 and this is a power of 2. So I'm going to let u equal the content inside of the parentheses. And then we can manipulate the du if necessary. Here du would be 6x squared dx. That's a dx which matches. That's just x squared. This is 6x squared. So I'm going to go ahead and slide the 6 to this side. So it'll be a 1/6 du equals x squared dx. Now I think we can rewrite this perfectly. So like that. And then the main component is a u to the 5th. And then x squared dx is there, but that gets replaced by 1/6 du. And so 1/6 falls, that's this guy here. But then the antiderivative of that itself would be 1/6 u to the 6. It's just a coincidence that there's a couple of 1/6. They combine to give you 1/36 u to the 6. And u was that there, 1 plus 2x to the 3rd to the power of 6. And this is going to be evaluated from 0 to 1. And then so I worked it out by hand. I got 182/9 as my final answer. But if you want, you can just type that into your device at any point. But either way, this is the final result for this problem here. So I recognize that the derivative of that is just e to the x, which is up there. So I'm going to let u equal this here, because then du, right, the derivative of e to the x is just itself. The derivative of that is just nothing, it's just 0. And I think we now have a perfect match. So e to the x dx is going to be du upstairs. And in the bottom, it's just going to be u. And now we recognize this, that this is the derivative. I'll write it a little differently. The antiderivative of 1 over u is natural log. Remember that? Natural log of u. All right? And we put absolute values just to be sure, because you can never natural log a negative number. So by putting absolute value symbols, we guarantee ourselves, it's like an insurance, that whatever this is, in case that thing's negative, the absolute values will make it non-negative. And so we're basically done, but instead of u, you can drop in e to the x plus 2 plus c. So this is one acceptable answer. Technically speaking, I feel like saying this, technically speaking, you actually don't need the bars in this case, because e to the x plus 2 is actually always positive, because this is always positive and so is this. As a matter of fact, the graph of this would look something like that. It's always above the x-axis. So this is always positive. And since it's always positive, it's never in danger of being negative. So these absolute value symbols, it's actually not even necessary. But anyways, final answer. Now, what about this one here? So the integral from there to there of cotangent. Remember from pre-calc that cotangent is cosine theta over sine theta. I think that's relevant. Let's rewrite this as such. So instead of cotangent, let's write it as cosine theta over sine theta. And I did that because now I have sine and cosine, and they're essentially the derivatives of one another. Because the antiderivative of cotangent, I don't know. So I reacted to this by turning it into something else. And now what if you let u equal sine theta? And then du, I'm going to let it equal, well, the derivative of this, which is cosine theta, d theta. So my gut instinct was to let u be the denominator in hopes that the derivative of it would be the numerator, which it was. All right. So this is going to be the integral of, let's see, so the top is just du, and the bottom is just u. And so this is actually like the one we just did, right? So this is going to be the natural log of u, but it goes from pi fourths to pi halves. But now we know what u is. U is, what was it? U is sine. So this is natural log sine of theta. And this is to be evaluated from pi over 4 to pi over 2. So now let's plug in pi over 2 in there. So this is the natural log sine of pi over 2 minus natural log sine of pi over 4. Okay. And the sine of pi over 2, if you go calculator, pi over 2 is up here. The coordinates are 0, 1. Sine is the y coordinate, which is 1. So this is the natural log of 1 minus the natural log of sine of pi over 4 on a calculator is square root 2 over 2. Natural log of 1, that's actually 0. So it's just negative natural log of square root 2 over 2. So this is one acceptable answer. This can be rewritten in many, 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 many different ways. As a matter of fact, I feel like doing this. Let me move the negative coefficient to the top as an exponent. So you can fast forward through this part if you don't want to see this, but the negative could come upstairs to become an exponent to the argument. Now this fraction has a negative exponent. So to make it positive, you reciprocate the content inside of the parentheses. That gives you this. But then realize that 2 in the numerator is like square root 2, square root 2. And I broke it up into square root because it knocks out the bottom. So this is just natural log of the square root of 2. But that is just natural log of 2 to the 1/2 power. And then the 1/2 can come back to the front and give you 1/2 ln of 2. So this is just me being fancy. These are the same number, but I do propose that this looks a little more elegant.